guys, so here we have another problem, adding rational expressions. You may notice right away that our denominator is not the same, okay? So we've done problems in the past where the denominator is the same, and if that's the case, it's very simple because then all we have to do is add the numerator, right? Well, in this particular problem, and like the last problem we just went over, right, we need to make sure that we get the same common denominator between the two before we perform this operation of addition, okay? Same thing as when you're adding fractions, you need the same common denominator, right? Well, the same rule applies here, okay? So the first step you want to do is, if you can factor, you want to factor. So look throughout your problem, is there anywhere that you can factor? And it looks like right here, I can factor. Now this is going to be a difference of 2 squares, right? So I can rewrite this as the following. I'll have x, actually let's write it over here, I'll have x all over x plus 3, and then I'll have plus negative 18 all over, and we said a difference of 2 squares here, so x plus 3 and x minus 3, okay? So at this point, you may be looking at the problem, and you notice that, okay, our denominators are not the same. I have x plus 3 and x minus 3 here, but then I just have an x plus 3 here. So what are you going to do in order to get these denominators to be the same? And we did it in the last problem as well. Okay, so take a minute, think about it, pause the video if you need to, and think about what you're going to do here. Okay, so what you're going to do is you're going to multiply, right, both the top and bottom on this rational expression right here by x minus 3. Okay, that way we can get the same common denominator. And we do it to both the top and the bottom because this is a fraction, right? And if we only do it to the bottom, okay, it won't be equivalent, right? So we have to do it to both the top and the bottom so it remains equivalent, all right? So make sure you don't skip that step, top and bottom. So I'm going to multiply both the top and bottom by x minus 3. So x minus 3 and x minus 3, all right? So let's go ahead and rewrite this again. So you're going to distribute, right, this x inside the parentheses. So you're going to have here x squared minus 3x. And this is all going to be over x minus 3 and x plus 3. Okay, and then we'll have plus negative 18 all over x plus 3 and x minus 3. Okay. Well, now that we have the same common denominator here, all right, we can go ahead and add the top part or the numerator. All right, so we can go ahead and add the top. So let's erase this work so we can go ahead and perform that operation. And when we do that, right, we'll just have x squared. And again, you want to go from highest power to lowest, minus 3x, and then minus 18. And this is all going to be over x minus 3 and x plus 3. Okay? Now you may be saying at this point, great, I'm done, right? This is completely simplified down, but be careful because remember, if you have the same factor on both the top and the bottom, you can cancel those out and you can simplify it down further. So if you look at this problem on the top here, we have a quadratic that we can factor. So let's go ahead and factor this and see if we have a common factor on the top and bottom that we can cancel out. All right. And again, you can use the AC method to do this. I'm going to skip this part, but if you want, if this is not something that's very visual to you, you can use the AC method. All right. And again, if you need a refresher on that, go back and check out the previous videos. So when we factor this, we're going to get the following. We're going to have x minus 6, and we'll have x plus 3. And then on the bottom, we'll have x minus 3 and x plus 3. And you can see now that we do in fact have a common factor on both the top and bottom. It's going to be x plus 3, so we can cancel that out. And our final simplified answer here is going to be the following. X x minus 6, and then x minus 3. This is going to be our final answer, simplified answer. Okay? Now, if they asked you to provide any values for x that were going to make this undefined, so any values for x that would make this undefined, okay, when they ask you that, it's important that you use what you had before you canceled out a common factor. So for example, if I wanted to find any values for x that were going to make this undefined, I would go to what I had before I canceled out my common factor. So I'm going to use this here, and I'm looking at the x. Remember, it's undefined if you divide by 0. So what would I have to plug into x here that would make this whole bottom part 0? Well, if I plug in a 3 here, 3 minus 3 is 0. And then 0 times this factor will be 0, and that will be division by 0. So remember, division by 0 is undefined. We can't have that. So you could say here, x cannot equal, so we'll say x, we'll do it in purple, we'll say x cannot equal, so x cannot equal 3. Alright, let's go to the other one, the one that we canceled out, okay? Well, what would make this 0 if I plug in a negative 3, right? Negative 3 plus 3 is 0. 0 times this factor is 0. And again, we'll have division by 0. So x cannot equal negative 3. Now notice what would happen if you used your final simplified answer. You would say, okay, well if I plug in 3, this will become 0, and that's division by 0, so x cannot equal 3, right? So you'd only get half of the answer because you'd be missing this negative 3, right? So that's why you have to use what you had before you canceled out that common factor, right? That's important when they're asking for undefined values. Use what you had before you canceled out that common factor. And this here would be our final answer, okay? And that is it.